Hello, my name's Tim Gilchrist, and I'm here to talk about big data in healthcare and what that means for marketers and what they might need to know as consumers of products that propose to sell big data or machine learning. During this session, we want to cover the big data and what a definition of it is, the relationship between artificial intelligence and machine learning, because you'll hear both words, and how to be an informed consumer of these services that are starting to enter into healthcare in particular and marketing also. And how are you going to act and respond to these products that are out there as a healthcare marketer? We'll go through an actual application and try to take some questions. So here we go. Big data is really a term for a collection of data sets so large and complex that they become difficult to process. We create more data every day than existed in all the world before 2002. So healthcare in particular is increasingly moving digital. The problem is we're making more and more unorganized sets of data, like MRIs, physicians' notes, which are what we call in IT unstructured. They're notes, they're the narrative of a physician's encounter with a patient. Now, put on top of that, cell phones, wearable technology, the internet, social media mentions. These are all new forms of data that are also becoming part of the healthcare landscape. Now, big data and a thing we'll discuss called machine learning are very adept at handling these types of unstructured data, these noise data. And they're very good at making sense of it. And even when some of the vectors or some of the pieces of data are missing. So it's great technology. And here, during this session, we're going to try to get to the bottom of how it becomes useful in healthcare and for a marketer in particular. So, artificial intelligence. And I picked this slide from The Wizard of Oz. And I'm trying to pull back the curtain on artificial intelligence here as well. You're going to get approached by a lot of people that are selling things called artificial intelligence that may or may not be very effective. And as a consumer of those services, we're going to talk here about what to look for, the questions to ask, things like that. Okay, so artificial intelligence is definitely here, but it's not evenly distributed. So when you think of artificial intelligence, think of Google's self-driving car, right? Probes that go to Mars and roam around autonomously. That's artificial intelligence. Machine learning is part of artificial intelligence, but it looks back to a much older tradition, and it's really just pure math. That's the difference really between the two, just as a rule of thumb. So artificial intelligence, sexy Google stuff on other planets, machine learning, much more akin to things that are around us every day. Generally, commercial applications lag way behind education and government. And the government's a huge user of artificial intelligence. Chances are people selling you AI will be misrepresenting their capabilities. That's just something that I've come across in my travels. Don't be fooled by the man behind the curtain. Always ask people, explain how your process works. And if they can't or won't explain it, you should probably look for another vendor. So my goal in this session is to give you a basic understanding of these concepts so you can be a more effective consumer, but not necessarily a practitioner of machine learning. Okay? Machine learning is going to be part of all of our jobs in the future. I really don't have much doubt about that because it's so powerful and it fits so well for healthcare. Think of the trend this way. First came the web, then came social media, which added data to the web in terms of people's conversations that are being recorded every day. And now machine learning adds another layer of technology onto all of our jobs. And it, as well, will help us understand what consumers really want, consumers really need, and in healthcare, what are the risks and exposures to people based on data that we've never even had before, like things they say in social media, or their purchasing habits, and of course, their medical records. So that's what we're going to try to do, pull the curtain back today. And so let's give some examples of where machine learning is all around us. Okay, so it's simple definition here. It's the construction and study of systems that can learn from data. When I say learn, I don't mean learn like a person learns. I mean machine learning software can look at the success or failure of an estimate or a guess that it made in the past, and then it can add those successes and failures into new processes and get better and better as time goes on. So it learns, but it doesn't really learn the way a person does, at least not yet. So again, machine learning is a subdomain of artificial intelligence, and I think for the purposes of this presentation, machine learning is the term I'm going to use. So machine learning's all around us. Just quickly go through these. Your spam filter in your email uses machine learning. And when I say learning, I mean when you put an email into your spam folder, that's telling the software this is spam. And it then learns by analyzing the contents of that email. And it will look for new emails from the same sender or that are constructed in a similar way to then put them in the spam folder and save you the noise in your inbox. So that's been around for quite a while, and we experience it every day. Google, same thing. When you do a search in Google and you follow the link in the results, you're telling Google that you like that response. When you don't follow a link, you're telling it that you don't like the search finding. And it learns from that, and it makes your searches better and better. Siri, very similar. You speak into the microphone, and it makes estimates or guesses as to what the words were and how they relate to actual words in a vocabulary. So your speech is what's exposed to the machine. It makes guesses on what it thinks you said and either performs an action or gives you those words back. eBay, another great example, they just bought a company called Hunch. Hunch is a really cool company that is able to determine purchasing patterns with generally an 80% accuracy just based on a few very simple questions. eBay is using Hunch to better estimate or better make guesses on your purchasing habits on eBay or things that it thinks you will like. Amazon, same thing. It makes predictions based on your prior purchasing habits. Netflix also tries to serve you up movies that it thinks you will like based on what you've liked in the past. These are all examples of machine learning. Now, one thing you won't see here is a healthcare company, and that's really sad because healthcare is perfectly adapted for machine learning because of the way data are collected and so much is known about the human condition in terms of what makes people sick, what makes people better. To my knowledge, there's really no public tool that helps people understand their health based on machine learning, based on other people's experiences, clinical research and things like that. So hopefully that'll change, but notice there's no healthcare company here now. So where did it all start? Everybody thinks machine learning is this brand new, sexy thing, but really it has its roots. A guy named Thomas Bayes, who died in 1761. He came up with a very famous theorem called Bayes' theorem. And all Bayes' theorem really says, and it's really awesome and elegant in its simplicity, is that you can combine prior probabilities, so odds of something that we know happening, like winning the lotto, right, combined with new observations to make our probabilities and our hypotheses better and better and better. So that's where the learning part comes in. So Bayes is a great fit to healthcare due to the presence of hypothesis being a diagnosis and events, which are tests, observations, and outcomes. It fits really, really well. Bayes has been around for a long time. Bayes is still part of of many advanced machine learning tools. You'll see the name, deep down in the tool, and I think it's really cool that it's been around this long. So when you think someone comes into your office and says, "I'm going to sell you machine learning," you go, "Oh, Bayes' theorem," and their jaws may drop because you know more than they do possibly about machine learning. So that's where it all came from. Now let's give a healthcare example that I think is going to expose some pretty interesting facts. So I use mammograms as an example, and these data are based on women over 40 who've had mammograms, and I've pulled these from the National Cancer Institute. They're not all exact numbers because numbers vary, but here's what I'm trying to relate. That you look at consumer sites like Hunch that are 80% accurate in predicting people's purchasing patterns. That's great, right? But healthcare lags so far behind in the application of these types of math, this understanding of data. It's really sad. And the bottom line is that about 80% of biopsies performed after mammograms are unnecessary. And this has touched, I'm sure, a lot of people's lives in this room. It certainly touched my life. And the problem is that physicians don't understand the math. So I'm going to walk through the math here of what happens when you get a positive reading on a mammogram. And I've divided the slides into orange parts are prior probabilities, right? Like what's your chance of having breast cancer as an over 40 woman. And then the blue portions or nodes are observations, okay? So that's how we're going to do it. So let's just walk through. So step number 1, you have an observation, which is a mammogram. Step number 2 is that test comes out about 10.2% of the time to be positive, okay? Third step is a biopsy. So in blue, this is an observation essentially when someone has a biopsy performed on them. And again, the numbers from the National Cancer Institute that are very generalized are of those people that tested positive on the mammogram, then had a biopsy, about 7.8% of them actually had cancer. And about 92.2% did not have cancer, even after having a positive biopsy. So when you run this through Bayes, okay, 7.8% sticks out. Unfortunately, when you ask a physician in general, what's the probability of someone having cancer after a positive mammogram, they will say the probability is 80%. So a big difference between what physicians think and what reality is. So 80 as compared to 7.8. So let's look at how this happened. This is where Bayes comes in. And I'm using this healthcare example first. We'll get to a marketing example. But this is the beauty of using mathematics like this to get to the real truth in healthcare. So what we know prior probabilities are that only 1% of women actually develop breast cancer over 40, and therefore 99% of them don't. This is before the test. We also know that 80% of mammograms detect breast cancer when it is there, which is great, but 20% miss cancer when it is there. We also know that 9.6% of mammograms detect breast cancer when it's not there. And that's the rough 10% you see in the first orange box. So therefore, 90.4 return a negative result. Okay. We also know that the tests throw about a 10% false positive. So when you put all those together and you run it through Bayes' theorem, the reality is that having a positive mammogram only means you have a 7.8% chance of actually having cancer. That's a powerful thing. Now, these data I've put together are just from population level data, millions of people. Think how powerful it would be if you also put observations in this little model about family history, the habits of the person being analyzed. Do they have a job that exposes them to chemicals? Things like that. Do they eat a lot of salty food? That's something that contributes to breast cancer. If you put all that together, you could refine the probability tremendously. And the relationship there to marketing is, think about this. This is a care path before us. You have a mammogram, and then you go through, you have a procedure, and then there's an outcome. It's a lot like a purchase pattern, too. And that's going to be my next example. Think about it as a journey. And machine learning, Bayes' theorem in particular, is really good at refining the probabilities of people's journeys. Okay? So, that's the health example. So, what's this really mean to marketing? Okay? Big data is about discovering relationships as well. Just like the mammogram example, you have a relationship between someone's personal habits, their family history, and observations about them, and their health. To a marketer, you can also discover relationships in people's demographics, what they say, what they do. Those things can be analyzed and good probabilities output that help marketers. So here's an example, real life example. This is one of the tweets that we got the other day. It says, "Can't beat a man with some insurance. I need that health plan, baby." Okay, so that's pretty funny, but in this tweet, there's a relationship. Obviously, someone is drawing a relationship between having a significant other with health insurance and a positive outcome. Okay? So, what can we do with this data? We can use this to do data-driven insights to inform a strategy. Maybe in this case, the strategy is, we should, look for people looking for significant others with health insurance, or maybe that's an advertising slogan or something. But there's a relationship that machine learning can understand and leverage. Okay, so another cut deeper. Let's look at the data that we have available to us in healthcare and what we can do with it. Okay? So on the top, I've got a care path, simple care path. Someone hurts themselves, they need an x-ray, they go to the doctor, they see a specialist, there's a procedure, and then there's an outpatient event. Now, this is similar to the mammogram. Okay? There's a care path there. Along the way, they're making data. So in the beginning, they might have cell phone data, there's wearable data, there's things they say on Twitter and Facebook. When the physician sees them, that data may be put up to a health information exchange. Further data could be a direct connection to a plan, as claims are paid, things like that. The data types across the middle, which I won't get into all of them at once, but we've got claims, we've got electronic health record, electronic medical record, ADT data, what location it happened in, what their prescriptions are, social media data that fell out of it, all this great stuff, okay? We can analyze this data in healthcare and try to determine what is happening. So the latency of this data is far superior to claims data that we've had in the past. So what is happening is huge, of course. And we can also use it to look at what will happen, okay? So examples there are, maybe we could determine when people need to see a doctor prior to them even knowing they need to see a doctor based on all these data. So that's more powerful than knowing after, which is where we find out today when the claim comes in. If we took the social data, maybe we could understand when someone's looking for a job or when they land a job, and therefore they might have a change in their health plan. That would be powerful information, because you would know before maybe even the person knew they needed to find a new health plan. You might know when someone required over-the-counter medication based on the things that they say in social. And wouldn't that be wonderful? It's another opportunity for a marker. There's no other category I can think of where these types of abundance of data help in the prediction of people's needs. Think about it. There's an old saying in car business that people, even 24 hours before they purchase a car, don't even know that they're going to buy a car. It's the second largest purchase you make in your life. But in healthcare, there's all these leading indicators that are driving at potential utilization of the system. But nobody takes advantage of it. So I'm going to give one example of a way we can do lead generation using machine learning. And I hope you'll like it and it makes sense to you. So here we go. This is text mining for sales. So the social media landscape for healthcare is basically filled with noise. So on the left, I have noise, people complaining about the government, advertisements, spam, things like that. And then on the right, we have this thing called signal, which is the information we want. And in this example, it's lead generation. People saying, I'm looking for a health plan. And this happens a lot on Twitter, We have over 1 million tweets a day regarding health. People talking about their health care in the United States. They're completely unstructured. There's no labels. There's nothing, that would help marketers sort of analyze that data directly. Surprisingly, lots of people are looking to purchase healthcare on Twitter, and a socially viable company. So when I say that, I mean a company that already has a social media presence and is trusted could take advantage of this signal, these leads, if they had the tools to separate it from the noise. And that's where machine learning comes in. You have all this noise, which most salespeople wouldn't even bother looking at, but if you can filter out the signal out of that noise, you have something really valuable. So let's walk through how this might work. So the first step is you have Twitter, right? And you're doing a rough search for anything containing the words health and plan. There's 1 million tweets a day fit that description. Then you create 2 databases. This is called your training database. You have negative outcomes, which you're determining as negative, and that's an example there would be people complaining about the government. Okay, you have no interest in talking to these people. On the right-hand side in the green, you have a positive outcome. Someone saying, hey, I need a health plan. Can anyone help me? This is an opportunity for you. You could train a computer with machine learning to then go and find tweets that match the green and avoid tweets that match the red or orange or negative. And that's a powerful thing. So how do you do that? We use a tool called Weka, which is out of New Zealand. The University of New Zealand developed this tool. It's a wonderful, very powerful desktop machine learning tool. And what it does is it performs what's called a string analysis. It looks at sentences and it makes observations of how the words are arranged in the sentence. And it weights the strings. So you see the little arcs there with the numbers. It's saying, I believe the relationship between these 2 words is significant given your training set. And I'm going to put this particular tweet aside versus discard it and show it to the market. So it's a very powerful tool that's now available right on your desktop. And the other thing it does is it looks through a text analysis and a demographic analysis. So in Twitter, you have in the box on the left, you have words like ACA pop up a lot, okay? And then it will cross-reference those words with any of the demographic analysis it can get, like the handle information, the number of followers a person has, their profile. There's a lot of words in the profile. And then even the location, date, and time are all relevant. When it puts all those together, you can get a nice stream of reasonably accurate tweets that are people just looking to purchase a particular item. In this case, it's healthcare. And no one follows up on this data right now. It's a gold mine, really. So if we perform all of these steps, right, what we get out the end is what's called a decision tree. Here we have the actual decision tree for people in California looking to buy health plans. So when you start at the top, imagine you got yet a lot of series of yes, no, yes, no. And it goes essentially, as you're looking at the slide, from top to bottom and from right to left. So if you follow the tree down the left-hand side, you'll see that people that use the word I'm, we've taken the apostrophe out here, but so it's relevant to me. The word pick, they're looking to pick a plan. Covered in California is the health insurance exchange, okay? And then me, the word care, and decide. So a fairly simple model there. But when you put all those together and you weight the relationships between those words in the tweets, you can take about 50,000 tweets and distill them down to 300 or 400 red hot sales leads, which is pretty interesting, actually, when you think about it, because there's so much noise. This model that I ran is 94% accurate at picking the leads out of the noise. So there's an example right there of how machine learning could benefit a marketer. Okay? We're taking something that was pretty useless, streams of tweets filled with junk, and distilling it down to just a very few qualified sales leads. So that's one process. So what else could you do with machine learning? So other uses. Taking that same approach as the sales leads, you can model who would be your most valuable customers, right? Look at the ones that are your most valuable, create a training database of just those, and then go look for more people just like them. Or who would be your most valuable Facebook follower, people that contribute a lot. You can focus your marketing efforts just on them. Machine learning, just like determining the signal from the noise in the tweets, is really good at determining sentiment. The sentiment values you get from your listening tool that you purchased really aren't that good. When you customize the listening tool using machine learning algorithm, you can get much more accurate sentiment. You can do marketing mix simulations. So if I do X, what is my potential outcome? Or a combination of X and Y. So imagine two different advertising medium, online, digital versus billboard. Run that model, get the actual outcome. You could create a tool that has a consumer-facing predictive technology, like taking all the information that you know about your customers, your members, integrating that with their social data, and then putting out predictions in terms of what we think, what the company thinks their health situation is. Or it could be used to run simulations in product development for a health insurance exchange. So what products perform well with certain audiences in certain exchanges. These are just some of the examples. So thank you very much. Enjoyed speaking to you. And please, as you enter the market of machine learning and artificial intelligence, be very wary of people selling you things. I really enjoyed the day. Take a few questions. Thank you.